A point charge with a charge of 4 times 10 to the power of negative 8 coulomb is 4 meters due west from a second point charge with a charge of negative 1 times 10 to the power of negative 7 coulomb. Calculate the total electric potential due to these charges at point P, 4 meters due north of the first charge. So let's do the part A first. We need to find out V1 and also V2. V1 is going to be K Q1 divided by R. And V2 is going to be K Q2 divided by R prime. K is 8.99 times 10 to the power of 9. Let's call this one Q1 and this one Q2. So that's 4 times 10 to the power of negative 8 divided by 4. So that's going to give us 8.99 times 10 to the power of 1, or 89.9 volts. On the other hand, we have this one, which is 8.99 times 10 to the power of 9. Q2, which is negative 1 10 to the power of negative 7, divided by this distance, which is going to be 4 squared plus 4 squared, 16 plus 16, square root of 32, which will be 5.66. When you calculate 8.99 times 10 to the power of 9 times 10 to the power of negative 7 divided by 5.66, that's going to be negative 158.83. Now V total equals to V1 plus V2. That's going to be 89.9 minus 158.83, and that's going to give me negative 68.93 volts. Or you can say joule per coulomb. Both of them are correct. Now in part B it says, calculate the work required to bring a third point charge with the charge of 2.0 times 10 to the power of negative 9 coulomb from infinity to point P. So work is going to be, when you have an infinity, it means that the electric potential is going to be 0, so that's not important. We can say W equals to negative Q3 times V, which is going to be V total. So negative Q3 is 2.0 times 10 to the power of negative 9 times negative 68.93. Then it's going to be 1.38 times 10 to the power of negative 7 joule.